Good day, my dear friends. Today, our next lecture, lecture number 8, is for your attention. In this lecture, we will know about second basic law of electrical circuit. That is Kirchhoff's second law. In this lecture, we should remember about the results of the previous lecture. We learn about the basic laws of electric circuits again. We will consider in detail Kirchhoff's second law. We will know that this law has two forms, two cases. This is a general and special cases. We will consider Kirchhoff's second law regarding the currents in the branches of the circuit, and we will talk once again about the duality in electric. In our previous lection we talked about three basic laws of electric circuits. That is first and second Kirchhoff's laws and the law of commutation. We know that all other interdependencies are consequence of these three basic laws. Kirchhoff's laws are universal laws. It means that they can be used for all types of electric circuits in all modes of its operation. We know that there are two formulations of Kirchhoff's first law. First formulation is algebraic sum of currents in node is zero. This is a general, this is a basic formulation. We can use this formulation in all cases. Second formulation is algebraic sum of currents in node is equal the algebraic sum of the currents of current sources connected to this node. This formulation can be obtained from a basic formulation, and we will use this formulation sometimes for calculation of electric circuits. We know that Kirchhoff's first law can also be written not only in terms of currents, but also in terms of voltages on the elements of branches in node. In this case, this equation are integral differential equation. In this lecture, we will get to know Kirchhoff's second law in detail. Once again, about basic laws of electrical circuit. We know that there is only three basic laws on electric circuits. That is first Kirchhoff law, second Kirchhoff law, and law of communication. We know that Kirchhoff's first law is the algebraic sum of currents in a node is zero. Today we will learn that the formulation of second Kirchhoff's law is the algebraic sum of the voltages in the mesh is zero. Please pay your attention about these two formulations. We will return to this and this formulation at the end of our lecture. And I'd like to pay your attention that when Kirchhoff was published this article, it was at 1945. Kirchhoff was only 21 years. And now about second Kirchhoff's law in detail. The formulation of this second law is the algebraic sum of voltages in the mesh in zero. This is a mathematical formulation of this law. In previous lecture, we already talked about the fact that in algebraic sum, each component can have either a plus or sign or minus sign. Therefore, before composing the equations according Kirchhoff's second law, we must decide on the rule according to which we will put the signs in this equation. In Kirchhoff's second law, we are talking about the meshes of electric circuit. For example, this mesh. And the mesh, as we remember, is a closed patch along the independent branches of the scheme. We can follow this patch only in two directions. First direction is clockwise direction, or second one counterclockwise. Let me agree that we will always go around the mesh clockwise. We will refer to this direction as the conditional positive direction of bypassing of mesh, for example, like this. When we have chosen the conditional positive direction of mesh, we can formulate the rule of signs in the equations of Kirchhoff's second law. These rules are: if the voltage coinciding with the bypass with the positive direction, it will be taken with a plus sign. And if the voltage is not coincident with the direction of bypass, we will take it with a sign minus. Consider, for example, this mesh. This mesh consists of 4 independent branches. You can see the element of branches of this scheme. Let we know about the directions of current at each branch of this scheme. If we know about the current's directions, we know also about the voltages in passive elements of this scheme. Do you remember directions of current and voltage in each passive elements are the same? So we have for our example 8 different voltages on each of 8 elements of this scheme. The directions of these voltages you can see it marked as these blue arrows. According to our rules, we can assemble the equation of second Kirchhoff's law for our example. Let we begin our page from this node, and we will going clockwise like this arrow. First voltage in our patch. This is voltage on resistor R1. This direction of this voltage is the same with the directions of positive direction. So we will write this voltage in our equation with a plus sign. Voltage UC1 on this capacitor has the same directions 2 plus sign plus 2 in our equation. Now we are in the node number 1, and then we go from the patch from the branch number 2. Voltage on resistor number 2 is coinciding with the bypass direction. We have plus sign in our equation. A few words about this element. This is a voltage source, and we know that voltage on this element and the electromotive force of this element, this arrow has contrary direction. So if we know the direction of electromotive force of this source, we know the directions of voltage of this element. By the way, the value of this voltage and the value of electromotive force is equal. When we pass through this mesh, we meet voltage on this source coincide with our positive directions. We have plus sign in our equation. Now we are in this node and we go contrary to through the current I3. That's why we have minus sign on voltage on inductor L3 and voltage on resistor N3. And now we have rise through this branch. Voltage of this source E4 is contrary directions of its electromotive force. It have minus sign in our equation, and we must to have a positive plus sign before UC4. This is voltage on our capacitor. This algebraic sum is 0. But when composing the equations according to Kirchhoff's second law, we can include in our mesh not only some individual voltages, but also the composite of this voltage. Look, for example, on this picture. We have branch number 1 and not number 1 and not number 2. We have two elements between these two nodes. This element R2 and E2. We have the voltage on each of these elements. But we can also say about that between the two nodes is the some voltage too. Let we denote this voltage as U1, 2. Then we will go from the mesh by another way. Let we start our page in this first node, and we will going not to this branch, but this voltage U1, 2. We are going clockwise. That's why we can write this voltage with a plus sign of Kirchhoff's second law. Now we are in this node, and we can rise through this branch to return to our first node. We meet voltage voltage on this source with contrary of our bypass direction, so we have plus minus sign of each this voltage, and voltage UR2 directed the same, so we have a same sign with UR2. From this equation we can found, for example, each of this voltage if we know second voltage of this equation. This is a general case of denoting Kirchhoff's second law, and we can use this case in any cases for any electrical circuit at any operation mode. But there is a special case when the mesh is formed only by branches of the circuit that do not contain current sources. Remember that electromotive force of two these sources we already know. So if we know its values, we can rewrite it on right side of our equation with contrary signs. So from in this side of our equation we have voltages on passive elements of our circuit. These voltages we will name the voltage drop. Voltage drops, this is voltages on passive elements of our circuits. From another side, we have algebraic sum of electromotive force of our two sources. That's why we can say that in the mesh the algebraic sum of the voltage drops, algebraic sum of the voltage drops from this side is equal to the algebraic sum of the electromotive force of voltage sources. Pay attention that we inverse this sign in our equation. So the sign rule for the right-hand side of this formula is as follows. If the direction of the electromotive force of the voltage source coincide with the direction of bypassing the mesh, then a sign placed in front of the corresponding electromotive force is plus. For example, we have in this picture direction electromotive force of this source and direction of our positive direction is the same. So in this side of this formula we have sign plus before this E for electromotive force. And if the direction of electromotive force is opposite to the bypass the meshing, we will write this electromotive force with minus sign, like this, minus E2. Why minus E2? Because we are going to this branch down, and this electromotive force is up. Now I will talk how we can rewrite our equations according to Kirchhoff's second law in terms of currents in the branches of our mesh. Let me look again to our example of our mesh, and in previous slide we wrote these equations according to each voltages in elements of this mesh. But we also know that there is some relationships between voltage and current of passive elements. So if we have voltage of some elements, we will rewrite this voltage through currents of these elements, like it's shown in this table, for resistor, for inductor, and for capacitor. So we can rewrite this equation in terms of currents. For voltages of voltage on R1, this is a first resistor, this is a resistor, we can use this formula, and we will write that U1 is equal resistance of this resistor R1 multiplied by current of this resistor. In our case, this is I1. So next voltage is a capacitor voltage, and according to this table we should use integral 1 over C1 times integral I1, this is a current of this capacitor, by dt. Then plus UR2, this is a voltage of this resistor, and current of this resistor is I2. Voltage is R2 times I2. Then we have electromotive force E2, and we have minus voltage on L3, on these elements. This is inductor, and voltage on inductor is connected with its current by this formula. In our case, we should write L3 times derivative I3 with respect of dt, and so on. So we can rewrite each equation of second Kirchhoff's law not only in terms of voltage, but also in terms of currents. This equation will allow us to calculate electrical circuits. And let we talk once again about the duality in electric circuits. In our lecture number 6, when we studied about nodes and meshes in electric circuits, we said that a node is called independent if it has at least one new branch that doesn't belong to other nodes. The formulation of independent mesh is quietly same. A mesh is called independent if it has at least one new branch that doesn't belong to the other meshes. So we know that node and mesh is duality conception. This is a new line in this of our duality list table. In previous lecture we know about this part of the duality table, but today we can add this table by two new duality conceptions. First conception is mesh and node. This is duality conception. This is a formulation of Kirchhoff's first law, and today we know about we are knowing about the formulation of Kirchhoff's second law. Algebraic sum of currents in the node is 0, and algebraic sum of the voltage in the mesh is 0. We know that node and mesh is a dual concept, and so we can conclude that currents and voltages is a new this is a dual concepts too. So we can say that this formulation is dual to this formulation, but this is a formulation of first Kirchhoff's law, and this is a second Kirchhoff's law. So we can see that Kirchhoff's first and Kirchhoff's second law are the dual laws. And this not a finish. This list we will be continue in our next lectures. Our lecture has become to an end, and we can make some conclusions. We know that all electric circuits obey only three basic laws. This is first and second Kirchhoff's laws and law of commutation. each other interdependence is consequence of these three basic laws. Kirchhoff's laws, first and second, are universal laws. That it means that it can be used for all types of electric circuits in all modes of its operations. We know now the two formulations of Kirchhoff's second law. First formulation, such as formula, is basic and can always be used. We know that the voltage on passive elements of our circles we will call it as a voltage drop. Remember, please, this name voltage drop. This is a voltage on passive element. So we can formulate this second Kirchhoff's law in second form. Algebraic sum of voltage drops of on elements of mesh are equal the algebraic sum of electromotive forces on this mesh. We write second Kirchhoff's law in terms of current, and we said that this form of writing this law will allow us to calculate electric circuits. The calculation of electric circuits is the topics of our next lecture. Thank you very much, dear friends, for your attention. Have a nice day. Goodbye.